Today we're going to be going over radicals and rational exponents. Now these are worth 5 points on your average SAT, but these skills carry over into other concepts and they're sometimes worth more, so this is definitely an important video to pay attention to. Our approach to these is going to be to identify radicals and rational exponents questions. We're going to break down the question, we're going to build a formula to solve them, and then lastly, we're going to solve a practice question together. So how do you identify these? Well, these questions will give you figures with exponents, and you need to know the correct exponent rule to solve them. So here's our exponent rules, and before we get into them, I'm going to make an important note that to use exponent rules, you have to have the same base. And what I mean by that is if we have x squared and x cubed, they both have a base of x, so that's okay. If we have x squared and y cubed, we have two different bases. We have a base of x and a base of y, so these two we cannot perform exponent rules on. Now let's look at our exponent rules. Well, anything to the exponent 0 is 1. Anything to the exponent 1 is just itself. Now if we have the same base multiplied by each other, the exponents get added. If we have the same bases dividing, you subtract the exponents. If we have power to the power, so if we have an exponent to the power of something, you multiply the exponents. And lastly, for square roots, you take the exponent of the inside and divide it by the exponent of the outside. So in this example, we have x to the a divided by b. A is the exponent inside, and b is the exponent outside. So here's a formula we're going to use for radicals and rational exponents. Step number 1, we're going to identify what we're solving for. Step number 2, we're going to identify and apply the correct exponent rules. And I say rule or rules because you might have one exponent rule you're using or you might have multiple. Step number 3, you're going to match the format of your answer choices. So step number 1, identify what you're solving for. Well, here I can see I'm solving for a divided by b. Step number 2, identify the correct exponent/exponent rules. So I can see here that we have exponents and square roots, and we also have exponents being divided. And so the two rules I think I'm going to use are the division exponent rule and the square root exponent rule. Now lastly, we're going to match the format of our answer choices. In this case, we don't have answer choices, but we can see that our answer is in this format x to the a divided by b. And so what that is telling me is we need to consolidate our equation into one singular x with one exponent, where the exponent is a divided by b. So I'm going to start with the first rule, and the first rule that I think I can apply here is this last one, the square root rule. And so we know that the exponent on the inside gets divided by the exponent on the outside. So for the numerator here, we have x, inside we have 7, and then a square root is just 2, so x to the 7 halves. On the bottom here, our exponent inside is 2, and our exponent outside is 3, so we have x to the 2/3. Now we can use our fourth exponent rule. We're dividing two bases that are the same. So since we're dividing these bases, the exponents get subtracted. So we can consolidate this to x to the 7 halves minus 2/3. And we need to make common factors so we can subtract these and make them one term like our answer. And so I'm going to make them sixths. So 21/6 minus 4/6. And this is going to equal x to the 17/6. Now finally, what am I looking for? Well, I'm looking for what this a divided by b term is, like we found in step 1. And it's actually right here, 17/6. So that's our answer. While these won't be directly useful in Desmos, you can use Desmos as a calculator always, and sometimes you'll be graphing exponents, so this won't be that concept specifically, but definitely know that if you get in a pinch, you can try using Desmos and see if it's helpful. So good luck on these.